In section 3.2, we're going to be talking about conditional and biconditional statements. A conditional statement is basically an if-then statement. If P, then Q. That P stands for our hypothesis and Q stands for our conclusion. And another way that you could see that is P with an arrow going to Q. So in example number 1, we'll do this in class. Identify the hypothesis and conclusion of the conditional statement. Statement is, if you live in Willoughby, then you are an Ohioan. Whatever phrase comes after if, that's always our hypothesis. So using that PQ symbol there, our hypothesis is you live in Willoughby. Our conclusion always comes after the word then. So our conclusion is that you are an Ohioan. Example number 2, we want to determine if the conditional statement is true or false. If it's false, we want to find a counterexample. So again, an example that proves it wrong. In example number A, if a number is divisible by 3, then it is odd. I would say that's false because I would think of the number 12. 12 is divisible by 3, but it's an even number. In part B, if two angles add up to 180, then they are supplementary. This would be a true statement. And then if we combine a couple of these, we have a biconditional statement. So that combines P going to Q, or our hypothesis going to our conclusion, and if it works backwards, then we represent like that symbol with the double arrows there. And we say P if and only if Q. So if a polygon has 4 sides, then it is a quadrilateral. That's our hypothesis. This is our conclusion. Let's see what happens if we reverse that statement. If a polygon is a quadrilateral, then it has 4 sides. The reverse is also true. If you could say that same statement going forward and going in the reverse, I could more accurately say it as a biconditional. So I would say a polygon is a quadrilateral if and only if it has 4 sides. That's a true statement. So let's look at this conditional statement. If you are from Willoughby, then you live in Northeast Ohio. Again, that's our hypothesis. This is our conclusion. If we reverse this, if you live in Northeast Ohio, then you're from Willoughby, that doesn't make sense. That's a false statement. While the conditional is true, the reverse doesn't make sense. The counter argument there, you could live in Lakewood, you could live in Tremont, you can live in literally any other town in Northeast Ohio other than Willoughby. So that would just be a conditional statement. I can't reverse it or make it a biconditional. To be a biconditional, it has to work both ways. Finally, in our last example, let's write the conditionals that come from a biconditional statement. The example that we have, you graduate high school if and only if you passed all of your classes. The two conditionals that make that up is, if you graduate high school, then you passed all your classes. That's a true statement. And the reverse, if you passed all your classes, then you graduate high school, is also a true statement. And that's kind of how we can see a biconditional is made up of a conditional going forwards and backwards. And that's it.